Hello, this is Mike Lively, and this is the fifth video in hacking Papervision. And what we've been doing is removing the number3D class from Papervision and using those classes internal to the Flash player. And we've been basically comparing the number3D class with the Flash player vector3D object and going back and forth. And last time we met a number of mathematical operations. We're going to cover those real briefly just to review. We saw the clone, which basically returned a new number in X, Y, and Z. We saw the copy to and copy from, which basically just sets, for example, we'll look at copy from, sets the components of an old vector to a new vector. We looked at increment and decrement, which we're very familiar with using the plus equals and the minus equals in single variables, but basically we do this for a vector, just basically increment a vector plus or minus, and those components were in the Flash player. We looked at modulo, which is actually the length, and that is just pretty much the what's called the metric many times, and that's just you take the components x, y, and z, square them, add them together, and take the square root. Then we looked at the normal, and basically what the normal does is takes that modulo, that length, divides it into each component of your vector and gives you actually what's called a unit vector. And now we're looking at the holy grail of 3D mathematics, and that's the cross product and the dot product. And let me kind of explain what those mean before we go and change those in display object. Let's go to the book chapter real quick. We're in chapter 2 and we're actually looking at a triangle. And basically triangles are made up of vectors. And typically when you're working with meshes, all meshes are made up of triangles, especially the economic ones. Not all of them are, but most of them are. And so I'm going to draw a little two vectors. Here's a vector, and here's a vector. And when I take the cross product of those two vectors, what I actually get is a perpendicular vector to that plane. So that's pretty cool, and that's really important. So many times people represent a perpendicular just by a little like part of a square right there to mean perpendicular. And that's really important because now what I want to do is use the dot product. Now why do I want to use the dot product? Because I want to do what's called clipping. I want to get rid of this when it's not facing me. Okay, let's draw those again. So if you look at my mathematical definitions, the cross product can be thought of in terms as A magnitude, B magnitude sine theta, and the dot product in terms of A magnitude, B magnitude cosine theta. That only explains them a little bit. There's actually a mathematical matrix way of actually developing them. We won't go through that, but here's a mathematical method for coming up with the cross product of two instance vectors. And here's the mathematical formula for the dot product of two vectors. And what I want to discuss is not necessarily how they obtain the mathematics, but why they're so important. So let's go back to our image and we'll talk about that real quick. Here's our image, and we'll redraw our vectors real quick here. So I'm going to find the cross product of two vectors, and what that gives me once again is a perpendicular vector to that plane, okay, or to that particular triangle in my mesh. So it's perpendicular, and as that mesh rotates away from me, that perpendicular vector will point away from me. Now, if it's pointing away from me, then I shouldn't be able to see it. So there's no reason to have it on the stage. We should just get rid of it. But how do we do that? Well, basically we have to draw another vector, and we'll draw another vector that's facing my camera, that's facing me in a sense, okay? And what I do is I take the dot product between these two vectors. So if I take the dot product between these two vectors, what is actually giving me in a sense is the angle between those two vectors. And so when the angle between the vector where I'm looking, okay, see this is the vector that I'm looking at, is 90 degrees, or this angle, or this vector is facing away from this vector, there's no reason to draw it. So what the dot product does, it takes two vectors, a vector that's 90 degrees to the particular triangle that I'm looking at, and the vector that's facing my eyeball. And when those two vectors are larger than 90 degrees, it pretty much tells us to clip that triangle, get rid of it, because my eye can't see it anyway. And so that's the importance of cross and dot product. Now let's go find their replacements. So I'm back in Flash Builder, and what I want to do is find the cross product between the z-axis and the up-axis. We're going to ignore up x-axis portion right here for the time being. We'll come back and address that later on in another series. Also below that we have another cross product, a z and an x-axis. We want to find that as well. And the cross product is just two vectors crossed with each other. So we're actually going to ignore this one right here. You can go back and look at the number3D code and figure out why I'm doing that. And it's very simple to do this. I want to do a z-axis cross, okay? And if I just do a little dot here, I can find out if there's anything in there. And there's a cross product, and it says just take the parenthesis of the other one. And I just come along here and take the parentheses of the y-axis. And that's all there was to replace that cross product. Let's do the other one. I want to cross the z-axis once again with the x-axis. And so I'm going to come along here and just put dot cross. And there's my cross product. Hit return. And just put the other parenthesis right there. And there we've replaced our cross products. Let's go ahead and save that. See if there's any more errors. And all the errors have gone away. Let's go back to our Package Explorer and see if we have any more errors in the program. And then we have org and we have core and we see there's an error, and let's go down to the error, and it's in our renderer. So let's go ahead and bring up our render. Let's go to command. Let's go to render triangles, and there's once again that number 3D. We want to get rid of that. So just highlight that and just get rid of it and put import flash dot geometry dot vector 3D. Got that. We use our Control F trick, and we'll just put in number 3D and replace it with vector 3D. Make sure you spell it right. Replace all. And so we got that. Let's save and see if we have any more errors. And all those errors went away. That's pretty good. Let's go back to the next one. And in my utils, I actually have a set of errors. So let's go to the utils. Mouse 3D has some problems. Once again, I see this number 3D. Let's get rid of it. And just import flash.geo.vector3D. Good. And once again, use my Control F trick and put in vector 3D. And replace all. And hit save and see what kind of errors we have left. Okay, that got rid of some errors, but I have some more. And I have a subtraction of vectors. And basically what does that mean? It's going to subtract one vector from another. How do we do that in the Flash player? So one of the first things I want to do is actually go back to the number 3D class. You can see I have it highlighted here, and just look at what subtract and add are. And basically all they do is subtract two vectors and add two vectors, and that's all there is to it. I bet I have a method like that incorporated in the Flash player. So go back to my mouse 3D, and we're going to go to the vector 3D, and we see there's subtraction. Let's hit a dot there and see if there's anything in there. And there's none. I can see I've got a little bit of an issue here. What I'm going to do is just, since I'm doing a target subtraction, let's just dot on this target because I know it's a 3D vector. Is there a subtraction? Yes, there is a subtraction. Basically, just dot that vector, hit the subtract, and just put the parentheses around position. So that actually takes care of that problem. Good. And then I have the cross product on the next one. So let's just go back and do our little cross trick. And I'm doing the z-axis, and I'm just going to cross it with the up. So basically cross product. Good, that's all done. Then I have another cross product below that. And so once again, going to do my little cross trick. Z-axis dot, and all that is basic code headings coming from the Flash player. And isn't that fantastic? So those, I think I've taken care of those four. Let's go ahead and save it, and let's do some error checking here automatically by the Flash player and see if those go away. I have one more problem, and what it is I actually left in a little bit here that I didn't need. This is target.subtract then position, and that's the way the Flash player subtracts two of those items. And with that, I got my modulo. So what is modulo? Well, that's length. So going through a few of these and figuring them out allows us to go more rapidly now. And we'll hit save. And let's see, and there's no more errors in that particular class. So let's go on to the next thing. And I see I now have an error in culling. So let's go to culling and fix that frustum color. And once again, it's the number problem. Let's get rid of the number 3D and import flash dot geometry dot vector 3D. Great. And let's do my replace. Control F, number 3D, and you here always say make sure you spell it right. And vector 3D, you can see there's been in the past I haven't spelled it right. And replace all. And let's see if that takes away our errors. And it does, so that class is fixed. Let's go to the next problem. It's in the geometry class, and it's in renderables, and it's in triangles, and we'll work with this next time. So things are moving along a little faster now because we understand all our replacements. So we'll see you next time. This is Mike Lively.